Okay, actually let's look at the calendar for a second so you see where we're headed. I gave you the worksheet. My goal is to work examples 1 through 3 today. I think we can do that. I'll assign 1 through 3 on the back is the homework, and answers are at the bottom. So today we'll do examples 1 through 3. I'll assign 1 through 3. And then Monday we'll do example 4, and I'll assign 4 through 6. All right, so you've got, this is another sort of like 2-day assignment. So you can divide it up however you like. With answers on the back. Yes. Answers with work shown are posted. So if you get stuck somewhere, hopefully you can read Miss Morris's handwriting, because I just stole her answer key. All right, if y is a differentiable function of t such that y is greater than 0 and y prime equals ky, let's rewrite that as, we're doing t, so dy dt equals kt. dy dt equals, whoops, not kt, but ky, sorry. So that's proportional. K is the constant of proportionality. Basically, we're going to quickly solve this thing. So some people are going to memorize what the answer is. I'm going to solve it real quick and see what we get. Whoops, can't integrate yet. What am I doing here? Separation of variables. dy over y equals k dt. Then we can integrate both sides. And I guess that's why they give you a point on the AP test for just separating the variables. Integral of dy over y. I've seen that 100 times in the last couple days. It's a little bit of an exaggeration, but maybe not much. Natural log of y equals k. Careful, it's the integral of k with respect to t. So it's kt. Careful, if it was integral of k dk, then it would be k squared over 2. But k dt would be t is the variable we're interested in, so kt plus c. Then we do the fishhook thing. Right, there's a base of e. We fishhook it around. E to the kt plus c equals y. And then we do that little c trick. C e to the kt. So what this worksheet is sort of proposing is that when you see this, you just have it memorized that it lands at this. And I'm saying that's fine if you remember that, but if not, it doesn't take but 30 seconds to get there. And since there's a variety of problems that look like this, my thought is it's probably not best to memorize. It's probably best to set it up and do the integration, because we're going to hit some different ones that don't look like this. So I would not do the memorize way. I would do the figure it out way, because that'll serve you better for all of the problems. All right, example 1. 10 grams of plutonium isotope Pu-239 was released in the Chernobyl nuclear accident. Chernobyl's in the news again right now, if you're following along at home. How long will it take for the 10 grams to decay to 1 gram? Half-life of Pu-239 is 24,100 years. That's a lot of information going on there. I think I would set up a table of values to just kind of keep track of everything. So we know at time 0 there was 10 grams. And at the end of the day, we want to know how long will it take for the 10 grams to decay to 1 gram. So the answer to our question is whatever time that is that matches up with that. The half-life is 24,100 years. So I think that's useful, because after 24,100 years, how much will be left? 5. Okay, so we got 2 points that we know and 1 that we're looking for. This also helps us if we wanted to get a guess for this, right? In another 24,000 years, we'd be down to 2.5. And then in another 24,000 years, we'd be down to 1.125. So that can get us sort of in the ballpark. All right. It tells us that this is a decay problem. So even though I just said I don't really want to memorize this, I also just did it. So I'm going to start with y equals c e to the kt. So how many constants are in this equation that I need to figure out to like fully define what's going on here? 2. C was the constant of integration. K was that constant of proportionality. So I need to find 2 things, which means now I know why they gave me 2 pieces of information. Which one do you think would be most helpful to use first? It's okay to use either one first, but one of them makes life a lot easier if we use it first.
0 and 10.
Probably the 0 one, because 0 makes things go away. So let's use the 0 information first. So 10 in for y. Again, there's still 2 constants, but what's k times 0? And what's e to the 0? 1. So what's c equal to? 10. Okay, so we're closer now. So y equals 10 e to the kt. Next, let's use the second piece of information, because we need to figure out what k is. So y would be 5 grams equals 10 e to the k times 24,100. The rest of this problem is algebra. There is no more calculus in this problem. That doesn't mean it's easy. Let's solve for k. What do you want to do first to get k by itself? We can unfish hook, but even before we unfish hook, this 10's kind of in the way. So let's move the 10 over. So 1/2 equals e to the, and then I'm going to write this just a little bit different because it looks better, equals e to the 24,100k. All right, some of you are going to unfish hook, which is fine. Others of you might natural log both sides. That's what I would do to solve this problem. But either way, you end up with the same thing. Natural log 1/2 equals 24,100k. So that means k is equal to natural log of 1/2 over 24,100. This would be a great time to get your calculators out. Or go grab one of mine if you need to. Natural log 0.5 divided by 24,100. Weird number. I'm going to need to use that more in this problem, so I'm going to store that. We don't do that much in here. We just did it in pre-cal a little bit. So I'm going to STO button on the bottom left, store, and you can call it anything you want, but since I called it K in my problem, it would probably be good to call it K here. So now my calculator knows what K is, and I don't have to write all that down, and I certainly don't have to type it all in with all the right decimals and times 10 to the negative fifth. Just let my calculator handle it.
Wait, didn't you have more time?
Yeah. The store button?
Yes.
So maybe zoom out a little bit here. So I get an answer. I'll do it on a different one. Let's say I get something really weird here, and I want to save that number because I don't want to write it down. I don't want to have to type it in. Whenever that number is showing up, you hit the STO button, STO, and it gives you a little answer arrow, meaning put that answer into, and then you get to pick what letter you want to call it. I'm not going to call that one K because I already have K. I could call it A. And then anytime I need A, it's in there. Anytime I need K, it's in there. And you can use that. You should use that. That way you don't have to type a whole bunch of stuff. All right, so now my calculator knows what K is. I don't have to write a decimal. Like if I'm working an AP problem, I don't have to write this out. Like that's K. Right? Like that's sort of a safe stop for K. I don't need to put a decimal there. Now what I want is how long will this take to get to 1 gram? So that means I'll use my final point, although there's kind of an unknown in the point. So 1 gram equals C, which is 10, e to the, I'm just going to put K there now because I know what K is. I don't want to write all that. That would be ugly. So I'm writing K, but it's not an unknown anymore. It's a known K. What I don't know is T. So this gets a little confusing because people see that and they're like, oh, there's 2 variables. And I would say, no, there's not 2 variables. There's 1 variable. K is not a variable. We know what K is. 1/10 equals e to the kt. And then either unfish hook it, which would be fine, or natural log both sides. So the natural log of 1/10 equals the natural log of e to the kt. And the whole point of natural logging both sides was to get that kt down front. And again, don't lose track of what are we looking for? Why are we doing that? What are we solving for in this problem? T. Trying to get T by itself. So what do I need to do to get T by itself? Divide by K. K is just a letter. Do I know what K is? Yeah, my calculator has that. So now I can go back to the calculator and do natural log of 1/10 divided by K. Actually, let's be careful. Make sure you're dividing the right thing here. $80,058. Normally we round to 3 decimal places, so I guess we'll do that, even though that seems a little bit unnecessary for this problem. Right, like 80,000 years from now, do we care about an extra 0.467 years? Probably not. And then check and see if that makes sense. Like we already said, if we halved it again, that would be 48,200. So I think 80,000 kind of makes sense. That's always the one advantage or positive of word problems is you can know if your answers make sense. Right? If you got 8 years, hopefully you know that wouldn't right. If you got negative 12 years, hopefully you know that's not right either. I guess I'd say today is a little bit of calculus and a whole lot of algebra. Example 2. A bacteria culture starts with 500 bacteria, grows at a rate proportional to its size. So that means dy dt equals k times y, proportional to its size. Proportional is the k, its size is y. Now, we've done this problem, so you either move things around and integrate both sides, or you can say, you know what, we've done this enough, I know what it looks like. I know earlier I said we don't want to memorize it, and now I'm just acting like we have it memorized, but either way, I just don't want to do the integration, the same integration 3 times. After 3 hours, there are 8,000 bacteria. I think let's set up a table of values again to keep track of these problems. There's always so much information that I think the table is the easiest way to keep track of it. So starts with 500. What does that mean in terms of our table? 0 is t, y is 500. After 3 hours, there are 8,000 bacteria. Okay, well, this makes sense. I've got 2 points to help me find my 2 unknowns. So c and k are constants. I just don't know what they are yet. Y and t are the variables. So be careful. Also, if you take a step back and you look at this equation and think about how far you've come in your math life, you used to think math was about numbers, and here's an equation with 5 letters in it. Right? Like, we know what they all mean. E is a constant that we know. C and k are constants that we're looking for this particular problem. Y and t are variables. So we know how to do it. It's just, you've come a long way. Just take a moment to recognize that. Pat yourself on the back. Find an expression for the number of bacteria after t hours. Okay, well that's sort of the expression, but that really wouldn't tell me how many bacteria there are, because I need to figure out what C and K are. Again, if you got a 0, use the 0 first, because it usually makes life easier anyway. So 500 in for Y, 0 in for T. This is fabulous, because what's C equal to? 500. So Y equals 500 e to the kt. Now, I want you to use the second piece of information to figure out what k is. So I'm going to pause the video and give you a chance to find k. And you don't have to give me a decimal for k. If you just have, you don't have to write down the decimal for k. If you write the equation on your paper and you have the decimal in your calculator, that's good enough. So algebra, 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 hopefully you get to there for k. Put that in the calculator, leave it in the calculator, don't use 0.924, use the full thing. Find the number of bacteria after 4 hours. So again, back to my table that helps keep all this information straight. So at 4 hours, I need to know how many bacteria there are. Y equals 500 e to the k, but I know k, so I don't need to write it out. Like my calculator knows k. Times 4. So this is actually easier than that last problem we did. This is just straightforward, type it into the calculator. $500 e to the k times 4. Look, I don't know, I don't want to minimize like how easy it is, but that's all you do. 20,158.737. bacteria. That's your answer, so you don't really have to put it in the table, but if you want to put it in the table, you can. Kind of keeps track of your information. Part C, when will the bacteria reach 30,000? So what am I doing with part C? Plug 30,000 into Y and find T. So I'm going to press pause again and give you a chance to do that. So 30,000 in for Y. And your job is to find T. Set up the equation, and then it's an algebraic equation from here. No more calculus. Divide by 500. Natural log both sides, or some of you have said like unfish hook it, which is fine. So if you can unfish hook it and go straight to there, that's fine. Like I see what you mean, like e to the kt equals 60. So if you can sort of visually do that, that's okay. Solve for t, so we'll divide by k. So I keep writing k, but k is not unknown. Like I know what k is, so don't lose sight of that. It's not a mystery. I keep writing it as k, but it's not an unknown. It's not even a variable. It's a constant. Natural log of 60 divided by k. 4.430 hours. And that's my answer. I don't have to go put it in the table because the table is just to kind of help me. But if I do put it in the table, it sort of makes sense. Like it sort of fits the pattern. Like, I mean, I can't tell for sure. But if I'd have gotten 300 million, I probably would be suspicious of that answer. If I'd have gotten anything less than 20,000, I'd be very suspicious of the answer. So making the table is a nice kind of reasonableness check on your answer. All right, one more today, and then the assignment will be 1 through 3 on the back. Newton's law of cooling. I don't know, for whatever reason, I feel like I should star this problem, probably because there's one like it on the top. How about that for novelty? The rate of change in the temperature of an object is proportional to the difference between the temperature of the object and the temperature of the medium. Whoa, that's a mouthful. Let's slow down on that. The rate of change in the temperature of an object. So let's call that, this is going to be rough because we're going to have, if I use T for temperature and T for time, then I've got dt, even though they're different T's, right? So I need to call it something else. It looks like they've opted for U for the temperature, so I'm going to say du dt, where U is the temperature of the object. It is perfectly okay to use a capital T and a lowercase t. Like if you want to use capital T for temperature and little t for time, that's fine. Just be careful. Make sure you don't get mixed up on which t is which. All right, is proportional to. Oops. So that means equals k times. The difference, subtraction, between the temperature of the object, that's what we call U, and the temperature of the surrounding medium, like the temperature of the room. Temperature of the room, TR. You could just do R. Room. RT, room temperature, or whatever. I was trying to avoid using T, and obviously I was unsuccessful. Let's pause for a minute. I think this makes sense. Like the rate of change of temperature depends on how big the temperature difference is. Right? So if let's say it's 70 degrees in this room right now. If I put something in here that's 75 degrees, it's going to cool off eventually to 70, but its rate is going to be pretty slow because it's close to room temperature. If I take something out of the oven and put it in this room, initially it's going to slow down, or it's going to cool down a lot quicker because that temperature difference is so big. Does that make sense? Does it sort of make sense of why this works? All right, example 3. Suppose that a roast turkey is taken from an oven when its temperature has reached 185. I'm going to have the table of values to keep things straight, because they're going to have a lot of stuff going on here. So that first sentence, what's going on here in terms of table of values? T0, and U, the temperature of the turkey. And we called it a turkey just to use another T, so just to keep things confusing here. Placed on a table in which the room temperature is 75. If U of T is the temperature of the turkey after T minutes, Newton's law of cooling, which will be given to you on a test, given when needed. Okay, so you don't have to memorize Newton's law of cooling. You gotta be able to use it, but you don't need to memorize it. If the temperature of the turkey is 150 after half an hour, what is the temperature after 45 minutes? Oh, there's something funny going on in here. What are they trying to mess with us on here? Half an hour versus 45 minutes? So it doesn't matter which we pick, we just need to be consistent. So do you want to work the problem in minutes or in hours? I think I would pick minutes as well. Otherwise we're going to have halves and 3/4, and I don't want to do that. Let's do it in minutes. So 30 minutes, it's at 150. 45 minutes, I don't know. That's what it's asking. Okay, so this is a different starting point than the previous two. So I can't just jump to that equation that I've jumped to before. I've got to slow down and actually calculus this problem. Separate the variables. Integrate both sides. Are you okay if I don't do a U substitution and can recognize right away what's going on the left-hand side? Do you know what du over u minus 75 is going to be? Natural log of u minus 75. And the absolute value bars aren't really necessary, because if my turkey starts at 150 or 180, whatever it was, it's never going to go below 75, right? It doesn't cool down below room temperature. That would be breaking laws of thermodynamics. So I do the E trick thing. Or the fish hook. And so U equals, see if I move things around, 75 plus e to the kt plus c, 75 plus c e to the kt. And we're out of time, but I think we're to the point where you can still plug in the 0. That'll tell you what c is. And then you'll plug in the next one, and that'll tell you what K is, and then you can answer the question. So assignment today is try to finish this example, and then do 1 through 3 on the back. So 3.5 problems for homework over the weekend. All we're going to do Monday is the last example and assign the last 3 off this worksheet. So if you get motivated, or you know you're going to have a busy Monday, you know enough to work the whole worksheet. I'm just trying to spread it out a little bit.